From a previous module, we talked briefly about how influenza viruses are categorized and named according to differences in their genetic material. So what are the processes by which these influenza genomes become so different? Well, it happens in two ways, known as antigenic shift and antigenic drift. So let's imagine an experiment where we look at genetic change over time. So on my x-axis, I have time, and on my y-axis, I'm looking at genetic change. So in this experiment, we take an influenza virus and we're going to freeze it. So we're not allowing it to replicate at all. And as a result, we have no genetic change over time. So now let's take a second influenza virus, and this time we will allow it to infect a cell and replicate. So as it replicates, it's going to copy its genome, which for influenza viruses is made out of RNA. Now, as its genome is copied over and over again, it's going to make these small mutations. So we see an accumulation of genetic change over time. This is especially true for RNA viruses like influenza because RNA doesn't have a proofreading mechanism like we have in our DNA genome, which prevents these mutations from occurring. So this process is called antigenic drift. And really, this can happen for all kinds of viruses, not just influenza. So what is unique to influenza A viruses is the ability to undergo huge amounts of genetic change in a short amount of time. So let's take an influenza virus in yellow, and same as before, we let it infect a cell with some other influenza A strains and go on replicating, and all of a sudden we see a huge jump in genetic change. And then it might go on replicating as same as before, it's accumulating these mutations because it's undergoing antigenic drift, just like we saw in the other virus. And then maybe again we see a huge change in genetic material. Now these huge changes are much bigger than just a bunch of point mutations here and there. This is an entire section of the genome that's changing, right? This is what we call antigenic shift. And this is really a special characteristic of influenza type A viruses. So as I mentioned before, influenza A viruses can undergo antigenic drift as well as antigenic shift. Influenza B viruses, on the other hand, can only undergo antigenic drift, same as any other virus can. So let me explain in greater detail what's happening with antigenic shift. Let's take two influenza A viruses. And if you remember from a previous module, we talked about how influenza A viruses are named according to the different surface proteins that they have. So we're going to call this one H5N1. And we'll call, actually, you know what? Let's call this one, we're going to call this one H1N1. And we're going to call this one H5N2. So it's got H5 surface proteins and N2 surface proteins. So what makes influenza viruses so unique is the fact that their genome is segmented into 8 pieces. So I'm drawing 8 pieces of RNA in each of these influenza A viruses. So let's say that these two different strains of influenza A infect the same cell. When they infect the same cell, they have the opportunity to shuffle their genetic material around. So all of the RNA pieces from both influenza A viruses are now in the same cell, and a new virus is produced. This new virus can have genetic material from each of the parent viruses. So in this situation, this new virus, we're going to say it has the H5 surface proteins and the N1 surface proteins. So this is an H5N1 virus. So it got the H5 surface protein from this parent virus, and it got the N1 surface protein from that parent virus. Now, this is a brand new influenza virus with new surface proteins that our immune system has never seen before. When antigenic shift occurs in a population, this is when we have huge pandemics because the human population isn't able to defend appropriately against this new virus. So that's the story with antigenic shift and drift, and it's definitely an important one because it shows how influenza viruses can potentially be so dangerous.